All right. So section 3.1 and 3.2. So they kind of lump them into one section. Graphing linear equations in two variables. So number one is right here on your workbook. This says plot the point. So this is just an exercise to figure out, okay, do you remember which one goes first? It should be straightforward. Just in case, we got to do it. So here we go. Okay, in the middle will be better. This is on page 19 on the workbook. So their drawing is much prettier because it's printed. Mine is not. So look at part A. So it's literally just, we'll plot a few and then we'll move on and see if you can identify on the next part. Okay, so 4.2. What is the 4? What is that 4 referring to? Yeah, so the x is always first. So part A says plot 4.2. So it's always x on the 4. Y value is 2. So then you go up 2. Right? So this is my A. Nothing insane. Just make sure the mistakes I always see on exams is people flip it. They get dyslexic and they're like, you know what? 2 is x, 4 is y, and that's not true. So make sure it's always going to be x comma y, right? So part B, plot, let's say -3, 1. It looks like an I, it's not an I. So -3, 1. Which quadrant is it going to be in? All right, so remember, quadrants are counterclockwise. So let's just go ahead and label them. The 1, 2, 3, 4. So where is B at? B quadrant 1, 2, 3, or 4. Let's see. -3, 1. Yeah, it's in quadrant 2. So then I think they're going to ask later. They're not asking yet, but just to get used to it, so we know which ones are which. Might as well talk about it now. C. We'll do C, and then we'll move on to something else. -5, -4. Which quadrant is that?
Quadrant 3.
Yeah, quadrant 3. So 1, 2, 3, 4. That's going to be right there. I'm going to move that number. Okay, so that is C and B. This is the X, and that is the Y. All right. Also, the signs of the numbers can give away what the location is, because over here, it's always going to be plus plus for X and Y. Over here, it's going to be negative plus. Here, they're both negative. Look like little faces. Over here, the y is negative. So there's some extra notes to remember. Like, all right, I see they're both negative. I know it's got to be 3. Right. So that also helps remember or get yourself straight. But anyway, we're going to move on to number 2. Let's see. Number 2, I think I'm going to share the book here. That's great. Dude, I always have issues in this room. Yeah, the little brother just messed up. One moment. I think I might just open the paper thing at this rate. Yeah, one open period. All right, who cares? So this one opens, not the other. Yeah, it's not bad luck today with computers, I guess. They need to come in. I need to put a ticket in and they can fix this desktop. I use Google then. I hate Google, but I use it. Okay. We'll use this guy. So back to chapter 3. I didn't want to draw all this. Just wanted to just go over and talk about it. It's the only reason I did this. So what would be the point for A? Can you see?
2, 6.
Yeah, so the 2, 6. Yeah, so that'd be 2, 6. What is the point for, let's say, I don't know, E?
5, 0.
5, 0. E is 5, 0. What about G?
2,
2, negative. As long as you get your which ones are X's and which ones are Y's, it shouldn't be too bad. I don't want to spend too much time on that, but guys, are you all comfortable plotting points? Not a big deal. All right then. Let's talk about intercepts. Let me give you some notes for how to find intercepts. So let me switch to this guy here. Okay. So make sure. And this is going to be for any function, not just lines, but we're mainly focused on lines here, but this is true for all functions. So to find, so let me make a note here for the number 1. The x-intercept. Let y equal 0. And solve for x. That's all you got to do. And then whatever you got, you're going to have this point. Some number x, right? Comma 0. That'll be your x-intercept. So number 2, y-intercept. You do the opposite. Let x equal 0 and solve for y. The intercept will look like this: 0 comma some number. Okay, some, call it C if you want. So first problem on page 20, example 3. I'm just going to write. The next few problems is going to say find the intercepts. I think I have space for one more question right here. Let's see. Okay. X plus y equals to 5. So this one's not too bad since the x and y don't have any factors or fractions or anything. So for the x-intercept, we said let y equal 0, right? So just let it be 0. Plug in 0. Solve for x, and you're pretty much done, right? So this is the intercept. As a point, it would be 5 comma 0. So that's what I'm trying to say here. Get your point. The intercept location is here. The homework may want just the x equal to 5, or it may want a point. So just read and see, what does it say? Did it say ordered pair, or did it say just a value? It should be clear. If not, let me know. Y-intercept. Do the opposite, right? Let x be 0. Solve for y. So in this case, it turned out to be, put parentheses just so it emphasizes that we plugged it in. They don't do anything. It's just there. There's our y-intercept. So we get the point 0 comma 5. So that's our first example, and we'll do a harder one in just a moment. But does that idea make sense? How to find intercepts? So on their picture, they want us to graph them by identifying the intercepts. So what you would do is you go plot 0, 5, which is right here, right? And then 5, 0, which is over here, and just connect the dots. That's it. So that's one method to graph your lines. Use the intercepts, and you're good. Okay. I think I have a line function in here. Yeah, it is. Cool. Arrows. Oh, yeah, I do. Anyway, any questions on that basic idea before we do harder ones? Like, okay. All right, let's do, let's see, number 5 looks harder, right? Let's try that one. The next page. You guys cool if I turn the page here?
Yeah.
All right. Example 5. Instructions will show the same. Find the intercepts. And graph the equation. So they gave us 2x minus 5y equals to 10. So let's do the x-intercept first. So x-intercept, which one should be 0? You remember?
So why?
Yeah, plug in a 0 for the y, and then we start solving for x. So here we go. So that part's going to disappear. We just have a 2x left. What is the next step? Right, we got a 2 in the way. 2 times x. So
You have to, divide by 2.
yeah, we're gonna have to divide by 2. So x is 5. So as a point, how would you write it? As a coordinate?
One. Maybe 5, 0.
Yeah, so the x value, we solved it, so just put the x down. And we chose y to be 0, because that's the only way to be on the axis. To intercept the x, the y must be 0. Okay. The y-intercept, do that over here. So which one should be 0 here? So 2 times 0 minus 5y is equal to 10. Negative 5y equals to 10. What is the next step?
Divide by 5.
Yeah,
So would it be, 2, negative 2? And what would be, the graph of negative 2?
Yeah, the point, let's see here. So we have the y, right? What was the x?
Oh, no, it was gonna be 5, 2, negative 2.
And what do we choose for the
0,
x,
negative.
right? That we chose the x. That was up to us. We solved for the y. And whenever you're working with intercepts, just don't forget, one of them has to be 0, right? Otherwise, it won't be an intercept. So here are the intercepts. So at this point, you can just plot both of them and draw a line. So negative 2, 0, negative 2, 5, 0. That would be 1, 2, 3, 4, 5. Will be here. Any questions on what they're asking you to do? Do you see how to, can you find the intercepts? Can you plot the points? Can you do your algebra to show your work?
So part of what you just did, you just took the, just add x and y, intercept at 0.
Yeah.
Just divide it by 0, just to kind of have that.
Yeah, so kind of think of it like, remember how we're doing the little tables for the points? You can think of it this way as well. So you know what? I chose 0 for the x, right? For this one. And when I solved all this nonsense, I get a y value that's negative 2. So this is the point. Over here, I chose the y to be 0. I did all the work and I found an x. So that's my point, right? So we've done that before. It's just showing more steps. Any other questions on this? Does it make sense? Okay. So the next one is the same type of stuff, but I think they're gonna start getting stranger. Let's do 6. And then we'll talk about these types of lines. Let's do 6. You guys cool on that page though?
Yeah. Nine.
6, I already forgot what it was.
After we do 6 per design.
We will do 9 eventually.
Okay.
We want to do 6, 7, 8 first. 7, 8 are pretty short, so I'm gonna talk about that real quick. But number 6 is the same instructions. So identify the intercepts and the graph. So let's do the X. So we let the Y be 0, right? Then we start. So now we got 3x equal to 7. We do the same stuff, but notice how we no longer have a whole number, right? We have a fraction. So we're just gonna have to deal with it. It's okay.
So on that fraction, when they just count the lines that go up.
Yeah, just
not
kind of.
necessarily the numbers, but just the lines, so there's lines in between numbers.
Yeah, you can kind of eyeball it and remember there's, for every whole, there's a 3/3, right? So this is really what? 2 and 1/3. So you can do, okay, 1/3, 1/3, 1/3 is 1, 1/3, 1/3, 1/3 is a 2, and then one more would be 7. You could also divide and change it to a mixed number to see it easier. Because 3 goes into 7 how many times? 2 times, and how much is left over? Yeah, so you could use, this is a little easier to see on the graph. That's up to you. You can also change it to a decimal and just kind of eyeball where the point goes on your calculator. However you want to do it.
Well, it will matter on the test, right? We will have to get a right, like if it's a fraction, we get that point right on the correct line or the dot or.
It should be, I mean, they should give you some flexibility. But if you show your work and you do it on the paper, then I'm gonna grade the paper. If it's right on the paper, then I don't care what you pick on the test, right? You pick the wrong answer, but your work's great, right? You're good. Mhm.
You can see it.
Yeah, I haven't looked at the homework recently, so I don't know how picky it is, but you let me know if it's being annoying. I'm gonna see if there's a tolerance I can increase. Okay, there might be, I don't remember. But anyway, let's do the y-intercept. So you let this guy be 0, right? Then we divide by -7. So x is -1. So what is the point for both of them?
You need to put a Y. So that.
Yeah. No, that's all good. No, this is important. We gotta fix that. Yeah, that why is twice. Sorry about that. If you see an issue, tell me right away. Tell me right away, because I don't want to get too far and then I gotta restart. So, like was it on Monday? Let's teach differential equations, and the one problem can take like 2-3 pages. And if I make a mistake on line 2, man, that sucks. That sucks big time. So you let me know anytime. Sooner the better. All right, so the coordinate for the x-intercept.
Well, it would be 7, 0,
0.
and then the other one would be 0, 1.
Yeah, that's it. So 7/3. I'm gonna use the page because it'll be easier to see. So 7/3. Is about, we said 2 1/3, right? That's the x value. So here's 2. So the third is like right there, kind of. Try to zoom in a bit. That's anyway. Can you guys see that? That's super tiny. If not, I'll put it in the paper. So it's right at the, on the 2, right after, 1/3 after. So it should be right on the axis, right there. So anyway, let me do it on the paper here. So plug both and connect the dots. That's it. So 1, 2, 3, 4. 1, 2, 3, 4. So 2 1/3 is about right here. About 0, -1. That's right there. So here's my line. Any issues graphing or finding the intercepts? Does that make sense? Now let's talk about horizontal and vertical lines next. You guys cool on this page? Make some notes for you for those types of lines. Vertical and horizontal lines. So the slope, this is number 1 for vertical, of a vertical line is undefined. And we'll have an equation of x equal to some number. Number 2. So if you see an equation that says, all right, graph x equal to 5, x equal to 2, whatever. It's just a straight up line at that number. Okay. The slope of a horizontal line is 0. And we'll have this type of equation. Of y equal to some number. So when you look at number 7, it says y is equal to -3. So it's a horizontal line at -3. So all you got to do is go there to -3. So 1, 2, 3, and notice that it's a straight up horizontal line. Okay, but there's one more thing I want you to remember. Notice how there's no X value, right? There's no X's here. But there are a bunch of X's plotted here. So this is saying, when you see this, this is telling you that no matter what X you choose, it will always give you a -3. So if I have 1, 2, 3, or -1, -2, -3, doesn't matter what X I choose, if 10,000, Y will be this the whole time. Okay, that's why you have this shape. See how it's choosing all the X's no matter what? Just keep going. And since there, and which we'll talk more about slope in a moment, but since there's no change, slope is 0, it's just constant. Doesn't go up, doesn't increase, it just keeps going. That's another concept you can think about. All right, slope is 0 because it's not climbing.
So that's how we would go beyond the ground.
But yeah, it looks like this. Any questions on horizontal lines? Okay, so let's do a vertical. All right, so go to 2. And then just draw a vertical line. That's it. So this is the opposite of this one. So no matter what Y you choose, you're going to get X equal to 2. So all the Y's are included forever, no matter what. X is 2.
So like when we see like that, they're just gonna run parallel to each other.
Yeah.
Like the last two questions we just did, like 7 and 8.
Mhm.
Like they're just gonna be so like the x-axis, which would be parallel to the y-axis.
Yeah, so X equal to 2, X equal to any number will have a line at that spot, which would be parallel to the Y-axis. Yeah, it's always straight up. And then the Y is always horizontal, which is parallel to the X. That's true. Alrighty, just real quick before we move on. So no matter what Y I choose, -10,000. X is 2. Okay. Any other questions on vertical, horizontal? We'll talk more about it in a little bit, I'm sure, when we get to this. Does that make sense though? As long as you see X equal to that, just vertical line. So. All right, so number 9, 10, 11. Let's talk about slope before we start. Apparently the San Antonio Zoo is expanding to include a gorilla habitat, Congo Falls. You guys cool on this page? Well, they better build a good enclosure. Shouldn't be able to hang out with them or jump down. All right, I'm turning the page. Okay. So let's talk about the slope intercept form. When your line equation is in this form, y equal to mx plus b, where m and b are just some real number, m will equal to your slope. So you can just pick the slope off right away if it's in this form. In other words, if it's solved for y, you got the slope. M is also equal to the formula y2 minus y1 over x2 minus x1. Conceptually, this is also the change in y over the change in x. Okay. B is the y-intercept. So if you have it in that form, you can just find the y-intercept right away without doing any work, which of course which can be written as a point zero comma b. So right away when you see this equation, you say, oh yeah, y-intercept's at b. Cool. M is slope. Who cares? All right. If it's not solved for y, you can solve it yourself to get that information. All right. These questions don't ask about slope yet because that's the next section. But I'm just going to go ahead and mention it so we can move on a little faster on 3 through 4. Okay, so first example. So for the next few, identify intercepts and the graph. So just graph it and give the intercepts. It's the same question as before. So y equals 2/3 x plus 1. So right away, what is the y-intercept?
Y-intercept.
Maybe as a
One, right?
yeah. So the b, right? The b is your y. So y-intercept will be simply 0, 1. So we don't have to do the work if it's in this form. Okay. Now, x-intercept, we still got to do it the other way. We let y be 0. Solve for x. So subtract 1, both sides, or move the 1 over, however you want to think about it. This will give us a -1, -1. -1 is equal to 2/3 x. So what's the final step? Yeah, divide. So -1 over 2/3 equal to 2/3 x divided by 2/3. Now I did say you guys can use your calculator if you want to. You guys ever check one out?
Where would I go for that?
I believe they do it at the math office, right?
Go to that house.
It might be. I'll double check in a second. So you gotta fill out the form first?
You gotta click on the link, you fill out a form, you then get an email, that you print the email, and print a copy of your schedule.
Hmm.
Two things you can go to the office.
Okay. I'll post that like that. It might already be in
You
there.
go, 'cause the students aren't being nice to people in the office. So make sure you do that.
I heard about that. That's crazy.
I'm not sure if it's like the original. TR30XA.
Yeah, it might not do the same stuff. So I mean, you don't have to get it. I mean, I think this one's like 10 or 15 bucks as well. If you want to get it yourself.
It's 22 at the bookstore.
Oh, here it's 22. Choose it online. Let's see. Curious. Huh? I thought it was cheaper.
I actually read it. Some people were saying, oh, it's illegal to buy them if they're like, with this certain color scheme, because they're like stolen from schools.
The school ones are like, school ones are this color, so. So on eBay, this one.
Let's see here.
Once you buy a bookstore, it's kind of black, gray, or silver.
Yeah, it looks like about. I guess it went up. Yeah, about $20.
Everything's going up.
Yeah.
Bro, even right, the landlord sent my mom an email for raising the rent $150. So I'm like, we're moving. I'm like, there.
Walmart has it for $16.99. Anyway, it's up to you. If you want to check one out or buy one.
What if that one went up?
That's fine, but you can't use that on your test though. You did-
Oh,
You can use that by yourself, your homework. All right, so -1 divided by fraction. 2/3. So the work would be that it flips over and you multiply, or you can use your machine. It's up to you. These cancel. We get -3/2. So the point would be -3/2, 0. You guys have any questions on this? You guys okay finding intercepts and plotting points? Not thinking about moving on to something else. -3/2 as a decimal, what is that? 1.5. So -1.5 would be over here, right? Is that right? And then this one? Right there. There's my line. Anyway. We're moving to 3,334, unless you guys have some questions or issues. Is it making sense?
yeah.
So let me know. Whenever I make no sense, just tell me. I'll explain it a different way. No big deal. Next one is the beginning of 3.3 and 3.4 has a long paragraph, which I don't really feel like writing. Let's look at the question in here. Okay. So page 23. Leroy started his driving trip 80 miles north of Austin. He headed north at 65 miles per hour. After every hour, Leroy plotted the distance he was from Austin versus the time he had been on the road. graph created, it's right there. Calculate the slope and interpret what it means. Alrighty. So we're gonna use that slope formula. Or we can also kind of pick it off the graph, just put that on paper. I'll switch. Switch to line dotted paper, I guess. Better. 3.3 and 3.4. Okay, so remember how we said it's the change in y and the change in x. So we could kind of eyeball it here and try if the points are pretty. Let's see. So let's say I pick this first point because it's intercept 0, 80, right? This one right here looks like 283. Looks like 3 and 280. So how far is this from here to here? What was a change in the y? Going from 80 to 280, right? And now if I look at the x value, I went from 0 to 0 to 3, right? So if we write down that idea, right? Let me switch over here. Write the formula down one more time. We said that the slope formula, so there's two ways to do this, also called m, is use the formula to subtract the difference, or subtract 2 points, y2 minus y1 over x2 minus x1. But also we said that it's equal to the change in the y, because the subtraction is basically giving you the difference, literally, right? It's the difference of two values. So what was the difference in the y's, you said? And it went up by how much? From 80 to 280? It went up by 200, right? Okay. What was the change in the x? It went from 0 to 3. Okay. Does that divide evenly? Doesn't look like it. So let's see if that's correct. So let's pick 2 points and use our formula. So we need an initial point, x1, y1, so we're going to call it. And the other point would be x2, y2. So we picked the first one to be 0 and 80, right? And the other one was 3, 280. Let's double check because I don't trust my memory that much. It's worse as we get older, you know. 3, 280, 0, 80. Yeah, we're good. Double check. Quadruple check. All right, so formula, the slope would be y2 minus y1 over x2 minus x1. So it looks like we got the same thing, right? See what I mean? So that is the answer. So let's see what it is as a decimal. See if it does it for me. 66.667. Approximate. I was gonna write this down just in case. Now let's interpret what this means. So what was this guy doing? What was this? What are these X values down here?
Hours,
Hours, right? And what were the Y values?
miles.
So he started 80 miles north of Austin. He headed north at 65. So every hour he went further and further away from Austin. So that's what's going on, right? Is that clear?
Yeah.
So when we get that decimal, what does that slope mean? What is the interpretation of 66.67? Like what's happening? I mean, it's not complicated, right? But there's, what is the slope telling us? Right, it's the average rate of change of the line, right? That's basically his rate. So every hour, he's going up by about 66, which makes sense because he's going at 65 miles per hour, right? So this is the average rate. It might have been equal to 65 if no, I think it's right on 280. So I don't think we chose wrong. No, I think we're good. And of course, it doesn't mean he's always at 65. According to this line, he might have sped up, he might have slowed down a little bit, right? Maybe he stopped, I don't know. But 66 would be the average rate all the way until that, assuming he keeps going forever, right? Does that make sense, the concept? Okay. Example 2. So that was our example 1. Example 2 says on I-10 outside of Kerrville, a TxDOT worker determines the road rises at a rate of 1.4 feet for a horizontal distance of 20 feet. Calculate the slope and write it as a percentage. Okay. We'll worry about that percent thing later. Let's just figure out what they're talking about. What is the slope here? So distance is 20. The road rises for every 20, right? You agree with that? Determine the rate of 1.4 for a horizontal distance of 20 feet. So, example 2. So I'm understanding that at every 1.4, for every 20 feet, it goes up 1.4 feet, right? Switch the camera. You agree? That's what he measured. So assuming that is constant, that's going to keep every 20 feet he moves across, it keeps going up in elevation, right? What is that as a decimal? If you divide this 0.07. Okay. What is that as a percent? Right, if to change the percent, all you have to do is multiply by 100%. So multiply this by 100. Yeah. Oops, I divided. Yep. So 0.07 times 100% gives us 7%. So there's a 7% increase as he moves along 20 feet. So every 20 feet. So that's our rate of increase as we keep going up. So if we were to draw a line, like the last one, we had that the rate of driving.
Uh-huh.
The rate would be 0.07 instead of 66. I was coming back from El Paso after Christmas, and it got so damn foggy. I could see maybe half a car in front of me. It's like the scariest thing. I was like 11 p.m. I was like tired. Been driving for 6 hours. I think that was the scariest thing ever. This sucks. For some reason, that little area near Kerrville that they're talking about, really, really foggy.
It does, I went to Sonora,
Yeah.
the last month.
It happens a lot. So I'm like, man, woke me right up though. I was like, just scared the whole time. And the roads and the 18-wheelers are right there. Yeah, for sure.
I drove all the way from like middle Tennessee all the way to Texas in like 14 hours.
Yeah, I drove from New York, to Syracuse area, all the way over here to Texas. 4 hours drive. No, I did it in a Mustang too.
That sounds horrible. I think we're just about out of time. You guys have any horn ponds you want to work on? Any issues you're struggling with? I don't want to. We'll stop here and continue 3, 3, 3, 4. You can stay for a few minutes after if you want. Just let me know. Hoping you guys have started the homework. Yeah, I would just put in a binder because we're going to be working on most of the problems in there. So we'll continue on page, I think it was 20, right? Page 23.
Page 23.
Yeah. So we're gonna get more into the slope. So on Tuesday, I'll rehash slope just in case you forgot, and then we'll continue slope problems. If you want to head out, you can. If you want to stay and do some problems, I'll stick around too. It's up to you.
Any help?
Yeah, this is a good time to have.
I think when I tried to like